Up to this point, we've talked about motion, where position is concerned, how position changed in time, and how the change in position changed in time. So, position, velocity, and acceleration. What we haven't talked about yet is what caused the changes in motion. What is the ultimate source of acceleration? This leads us to the subject of dynamics. Dynamics is the study of the cause of motion. You might also hear it being described as the study of forces. Before we dive into the details of forces, there's a few other concepts we have to define so we all are talking on the same level. The first of these concepts you have probably mentioned before in previous classes, and that is matter. What is matter? It can be a surprisingly hard concept to define, because it is the stuff that makes up everything you encounter for the most part on a day-to-day life. The operating definition we're going to use in this class is matter is anything with mass and that takes up a volume of space. Of course, this is somewhat of an oversimplification, but for the classical mechanics that we're studying, this will do fine. But to use the concept of matter, we have to define what it means to have mass. Mass is something you've talked about your whole life, but probably haven't defined. It is a quantitative measurement of an object's inertia. In the MKS version of the metric system, the measurement and unit we use to measure mass is the kilogram. In a CGS unit, it would be the gram. In the standard imperial units, the measurement for mass is a slug. Of course, if it's a measurement of the object's inertia, we'll have to define what inertia is. Inertia is the inherent property of an object's resistance to change in motion. Essentially, this is saying that matter that has mass won't up and accelerate all on its own. It has a resistance to an acceleration. It's worth noting at this point that mass is a scalar quantity. So it is a number, a value, that has no directional component. Mass is also measured from a scale that starts at 0. You can't have negative mass. It is also worth noting that mass is a property that is, at least in the classical sense, frame independent for a non-inertial reference frame. This means no matter who's making the measurement, as long as they're non-inertial, they'll get the same value for mass. A non-inertial reference frame refers to any reference frame or set of coordinates used in measurements that is not accelerating. It can have velocity with respect to another reference frame, but as long as it is not accelerating, it is considered non-inertial. All this really means in the long run is that mass is independent of who's making the measurement. It should be noted that mass is not weight. Weight is a force, and we'll get to that later. This brings us to the first of Newton's 3 laws. Each of these laws was laid out in the Principia centuries ago and ushered in the scientific revolution and revolutionized the entirety of human civilization. The first law, which Newton is attributed to, the majority of which was actually generated by Galileo. Galileo, though he didn't formalize it in the same way, came up with much of the concepts and laid the foundation which Newton later built upon. You might have heard Newton's famous quote that if I have seen further than those before me, it's because I have stood upon the shoulders of giants. One of those shoulders belonged to Galileo. The classic way of phrasing Newton's first law is the following. An object at rest tends to stay at rest, and an object in motion tends to stay in motion, unless acted upon by a non-zero net external force. Here the term net implies a sum of all the forces acting upon an object. External refers to any force coming from outside the object. And we'll get into this in more detail later in the unit about what counts as an internal versus an external force. Non-zero, by the way, can be positive or negative. Because forces are vectors, they have that directional component to them. A slightly less clunky way of phrasing the first law is as follows. Objects do not change their motion unless there is a non-zero net external force acting upon them. In other words, things tend to just keep on doing what they're doing unless something comes along and pushes them or pulls them. An even shorter way of saying the first law is any object with mass behaves with inertia. For this reason, the first law is often referred to as the law of inertia. Of course, that definition isn't too useful if you don't know what inertia is. Remember, inertia is just a property of an object, and its resistance to change in motion. It's worth reminding you at this time that when adding vectors, which we will be adding a lot of forces to find net forces, you have to take into account the direction. So when vectors are added, they are added head to tail. In this case, the three vectors add up to 0, giving us a net force of 0.